The reading speed of third grade students is approximately normal with a mean of 160 words per minute and a standard deviation of 20 words per minute. If a sample of 25 random students is asked, find the mean and the standard deviation of the sampling distribution. So we have the population mean and we have the population standard deviation. So the population mean is equal to 160 and the population standard deviation is equal to 20. We need to find the sample mean of the sampling distribution of sample means and the standard deviation of the distribution of sample means. So the mean of sample means is the same as the population mean, which is 160. The distribution of sample means is equal to the population standard deviation divided by the square root of the sample size. In our case, it is 20 divided by the square root of 25, which is 20 divided by 5, that is equal to 4. Okay. If the number is not a perfect square here, you can just leave it in this format. You don't have to simplify it or find the answer as a simplest form. Find the probability that a random sample of 25 students will have a mean reading speed of at least 165. Notice the wording here. So we are given a sample size and we need to find the probability that the mean reading speed is at least 165. So the distribution I'm working on here has X bars at the bottom. This is distribution of sample means, which means I will need to use the new mean and new standard deviation. I will stick the mean in the middle, 160, and then at least 165. 165 is approximately here, 165. At least meaning it could be that, but more. So it is this area, it's area above. Okay, now we know how to find the area above. The area above is equal to 1 minus norm distribution of 165, comma the mean, comma the standard deviation, comma true. If you stick that into an Excel sheet, you're going to get the answer, which is 0.8944 rounded to 4 decimals, which is about, sorry, that was not the correct answer. This one, here we go. It's approximately 1 minus 0.8944, which is, if I do that, equals to 0.1056, which is 10%, 10.56%. Part C, find the 90th percentile of these 25 students. So again, we're still working with the sample information. So 90th percentile, if I want to visualize it, here is the mean, 60, 160. And 90th percentile is about here. I need to find the cutoff for that 90th percentile, which is this area right here. So this area is given. It is 90% or 90th percentile, which is equal to 0.90, and we need to find the cutoff, which is the mean value. So X bar in this case is equal to norm dot inverse of the percentile, comma the mean, comma the standard deviation. If you do that, the mean is going to be, so X bar is approximately 165.13 words per minute. So that is the 90th percentile cutoff. The last part in question number 3. What is the probability that a class of 36 students having a reading speed of more than 165? Notice how the sample size has changed. That means we need to compute a new standard deviation. The mean for the distribution remains the same, and the standard deviation for the distribution of sample proportion becomes the old standard deviation, the population standard deviation, I should say, divided by the square root of the sample size, which is in this case 20/6. You can leave it like that. And now, all you need to do is to illustrate the shape. So the shape is a normal distribution. Here is the mean 160, and then 165 is roughly here, 165. And we need to find the probability that the class is having a reading speed of more than 165. More than is the area to the right. So to find the area to the right, we say 1 minus norm distribution of 165, comma, the mean, comma, the new standard deviation, comma, true. If you stick that into a Excel sheet, it's going to give you 0.06681. If you round it, you're going to get 6.7%. So that is the last part of question number 3.